Section 6.1 Velocity and Net Change. The displacement over time interval AB is the change in the position SB minus SA. S of t represents the position at time t. The v of t, which is the derivative of the position function, is the velocity at time t. The absolute value of the velocity is the speed at time t. The displacement between t equals a and t equals b, where b is greater than a, is sb minus sa, or the integral from a to b of the velocity vt with respect to time t. The distance traveled by the object between t equals a and t equals b is integral from a to b of the absolute value of the velocity vt with respect to t. These two diagrams represent the difference between the displacement and the distance traveled. As you see, the first one, the green area A1 is positive, the red area A2 is negative. A1 minus A2 represents the displacement, or the definite integral from A to B of the velocity vt. The distance traveled is the quantity A1 plus the quantity A2, or the definite integral of the absolute value of the velocity vt with respect to t. The first example, a cyclist pedals along a straight road with velocity vt equals 2t squared minus 8t plus 6 miles per hour for t between 0 and 3, where t is measured in hours. Part A, graph the velocity function over the interval 0, 3. Determine when the cyclist moves in the positive direction and when t moves in the negative direction. For the function v of t equals 2t squared minus 8t plus 6, this is a parabola. We observe it's going to be the parabola opens up. Let's find the y-intercept. V at 0 is 6. For the x-intercept, let's solve for t by factor 2 out. So 2 times t squared minus 4t plus 3. And factor completely, we have 2 times the quantity, t minus 3 times t minus 1 equals 0. We get two intercepts at t equals 1 and t equals 3. Let's sketch the graph. The graph opens up. The vertical intercept, or the v-intercept, is at 0, and the horizontal intercept is at 1 and 3. For the interval from 0 to 3, we have positive area between 0 and 1, negative area from 1 and 3. Therefore, the velocity vt is positive on the interval between 0 and 1. Therefore, the cyclist moves in the positive direction. The velocity negative on the interval between 1 and 3. Therefore, the cyclist moves in the negative direction. Part B, find the displacement of the cyclist in miles on the time interval from 0 to 1, 1 to 3, and 0 to 3. Interpret the result. Over the interval 0, 1, the displacement is s at 1 minus s at 0, or the definite integral from 0 to 1 of the velocity bt with respect to t, or the integral from 0 to 1 of 2t squared minus 8t plus 6 with respect to t. For the antiderivative, we have 2t to the third over 3 minus 4t squared plus 6t evaluated from 0 to 1. We obtain 8 over 3 miles. Next part, over the interval 1, 3. The displacement is s at 3 minus s at 1, or the integral from 1 to 3 of bt, and do the same fashion as the over interval 0, 1. We will get the quantity negative 8 over 3 miles. As you see, the area between 1 and 3 is negative on the graph. And in the next part, over the interval 0, 3, the displacement is eight over 3 plus negative 8 over 3, or 0. That means the cyclist returns to the starting point. Part C, find the distance traveled over the interval 0, 3. We are going to find the total distance. So the distance traveled over 0, 3 is the integral from 0 to 3, absolute value of bt, disregard of the direction, or the absolute value of 8 over 3 plus the absolute value of negative 8 over 3. That gives us 16 over 3 miles.